In this video, we're going to take a look at how we can use logarithms to solve exponential equations when we have x in the exponent. Before we get to that though, let's take a look at a very easy example. So in this case, it is exponential because we do have x in the exponent, but what people realize right away is that, well, the bases are the same on both sides. So in that case, we don't even need to worry about logarithms. Let's just ignore the bases and put our exponents equal to each other. Since the bases are already equal, all that has to be true from here is getting those exponents equal to each other. So this case doesn't take any logarithms, we just solve it like this. So I've got variables on both sides. I'm going to go ahead and subtract x from both sides, and at the same time I'll subtract 9 as well. And so I end up with that equation right there. If I divide both sides by 3, I come up with an answer of -3 for my value of x. So like I said, very easy example where we didn't even have to use logarithms. Let's take a look at two where we're actually using logarithms to solve. So in this case, my second example, I've got 4 to the x power is equal to 10. I want to get rid of that base of 4 and get the x out of the exponent. Well, recall that logarithms are the inverse operation of exponential things. And so what I'm going to do is use a logarithm to get rid of a base. And specifically, whatever that base is that I want to get rid of, I'm going to do that same log base to undo it. So because I have a base of 4 that I want to get rid of, I'm going to do the log base 4 of both sides. Recall that you're allowed to do whatever you do to one side, you have to do to the other side. It's true for addition, it's true for division, it's true for logarithms as well. So both sides of this, I'm going to do log base 4. Okay? So doing log base 4 of 4, those are considered inverse operations. You may want to go back and watch our previous video about this if you need help with that. Those will cancel out, leaving behind just an x. On the other side, I then have log base 4 of 10, which at this point I have ways to work this out. In a previous video we looked at something called the change of base formula to work this out. So if you want a quick refresher on that without going back to watch that video, the way this worked was we did log of 10, or natural log, divided by log of 4 as a way to work this out. Or some of you had a log base button which enabled you to just type this in exactly as it appears on your calculator. So either way, I'm going to go ahead and either use log base or do the change of base formula, log of 10 divided by log of 4, and come up with an answer of about 1.66. Alright, and then for our final example, I've gone ahead and upped the difficulty quite a bit. I want to go ahead and I want to get that x out of the exponent, but before I do that, I have to take care of all this other stuff around it, just like we always do when we're solving. And so first up is to take care of any addition or subtraction. So I'm going to start by adding 7 to both sides of this equation. So 4 times e, remember e is just a number, it's not a variable. So 4e to the -3x would be equal to 20. Next up, I want to divide by 4. 4 is not the base of the exponent, e is the base. So I can divide both sides by 4. I want to get that base isolated. So dividing both sides by 4 then leaves me with e, which remember is just a number, to the -3x is equal to 5. And so at this point, now I'm down to an exponential equation. And so to get rid of a base, I'm going to do a logarithm. Those are always inverse operations, just like we divided to get rid of multiplication. I'm now going to do a logarithm to get rid of the base I want to get rid of. And remember, we're always going to do the same log base of the base that I'm trying to remove. So in this case, I'm going to do log base e, or remember that log base e, if I want to just do this, is the same thing as natural log. So I'm going to do the natural log of both sides. Recall though, whatever you do to one side, you must do to both sides, and natural log is an operation. So doing natural log of e, those are inverse operations, they'll cancel each other out, and leave behind just the exponent, just the -3x. On the other side, I can use a calculator to find the natural log of 5. I found that to be about 1.61. Pause the video and try that for yourself if you're not sure. And then in this case, I have one more step to do because the x was not the only thing in the exponent. And so from here, I'll just finish like I normally do and divide both sides by -3 to get x by itself. And finally, after all that work, I come up with an answer of about -0.54.